This is a working model of a scanning optical microscope. It's not actually confocal yet, but it is capable of scanning a spot of light over a specimen and picking up signal from any part of the specimen that is reflective or shiny. The essential features are this light source at the top and this lens here. The lens focuses the light from the light source to a point just below here where I can put specimens. If there is a specimen in the beam at that place, some light will be reflected, it'll go back through the lens and up, and we have a half silvered plate here which can divert that reflected light off to the side to a light detector here. You can probably hear a rather irritating sound. That is produced in an amplifier by converting the light signal into an audible tone. And I'm doing that so that you can hear the serial signal that is generated as we scan the microscope. Now I'm going to show you where the focus is by putting this piece of paper into the beam. When I put the paper in, you're going to be able to see the focus, but you're also going to be able to hear how the signal is actually collected from quite a wide range of levels. Now, over here, mounted in this sliding arrangement, I have a specimen which models a biological specimen much more realistically because it has depth. At the top level, we have a shiny metal grill with many holes in it. At the second level, which corresponds to the level of the focus, we have metal plates in three groups. In the first group, narrow ones, and second group, broad and then narrow. And if we could pick up the signal from this layer, we would get the Morse SOS signal. It should go beep, 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 beep. And then at the bottom level, we have a continuous aluminium sheet which will reflect back all the time. So I'm going to slide this across, and this is exactly how the early confocal microscopes worked. You had stationary optics and you moved the specimen to build up an image. I think you'll agree that the Morse signal was very hard to pick up, if at all. But now I'm going to make this confocal. I have here an opaque metal plate with a hole drilled in it, and the position of the hole is set very carefully so that light from the focus actually is refocused by the lens into the hole. And that's the essential feature of a confocal aperture. So I pop it in, and the first thing you'll notice is that the sound has gone away. The signal level has been cut down enormously. But let's slide the specimen in as before. Did you hear the Morse signal? And I try again. So by introducing the confocal aperture, we've sacrificed a lot of signal, but we have gained discrimination of depth.